Hello everyone, this is me, Arijit Ray, and here comes your online classes for Class 10 ICSE from Accentus. Today we'll be discussing refraction of light at plane surface, and in this chapter, the initial phase, this video is a recap video. So we'll be just going through the topics that we have already covered. Let's check it out. Here we go. We can see on the board that the nature of refraction and what is refraction actually. You can see it on the board, and you can see the diagram that we have a general rule that light ray follows, and that is when it enters from a optically rarer to optically denser medium, the refracted ray will go towards the normal. Normal is the line which is passing through the point of incidence, you can see in the diagram. And eventually when light ray travels from optically denser to optically rarer medium, it always goes away from the normal. Okay, that we can see in this video. Hope you can understand. These we have already covered. Okay, please concentrate on the topic. Now we can see the laws of refraction. We can see the incident ray, the point of incidence, the normal drawn on the point through the point of incidence, the refracted ray, the angle of incidence, the angle of refraction, which are marked as I. Angle of incidence is I and angle of refraction is small r, that we can see here. And also the Snell's law, which states that for a monochromatic light and for a particular pair of media, the ratio of sine of angle of incidence to sine of angle of refraction bears a constant ratio, which is written as mu, the Greek letter, which indicates the refractive index of the second medium with respect to the first. I have written, like you can see, 1 mu2, it is refractive index of the second with respect to the first medium. Okay, depending on from which medium the light is coming and where it is entering. You can see this now, sin I by sin r equals to 1 mu 2. This is the recap video number 2. Hope you have understood this one. And now we'll go into the further topic, defining the refractive index and with respect to the definition and everything, and how we can measure it. So hopefully you have already gone through the recap sessions that we have already covered in earlier classes in March, first week and the second week. So I'm starting from there only. Here you can see the one example that I have done based on the refractive index, the definition of refractive index, which is very simple. As you know, it is the ratio of speed of light in the first medium from where the light is coming with respect to the speed of light in the medium where light is going. Okay, so if we want to calculate the refractive index of glass with respect to water, that means we are assuming that light is coming from water to glass. So we can simply put the values of speed of light in water, which is 2.25 into 10 to the power 8. You can find it in your book. And the speed of light in glass is 2 into 10 to the power 8. And dividing, we are getting a value which is 1.125. And in the second example, you can see we have done the reciprocal of it, the reverse of it. That means now light is traveling from glass to water, and we are doing the same thing, but it is just the reciprocal of the previous, and we are dividing 2 into 10 to the power 8 meter per second by 2.25 into 10 to the power 8 meter per second, and finally the answer is 0.89, which is exactly the reciprocal of 1.125. So this basically states the principle of reversibility of light. That means the way light enters from water to glass, it will follow the same path when it goes from glass to water. Okay, this actually exhibits this simple phenomenon which is known as, I repeat, principle of reversibility of light. Alright? Let us now see how light ray travels through a glass block. Now this is very interesting. You can see the diagram on the board, and what we can see here, that incident ray is incident on a glass block, and also we are tracing the path of the light ray, assuming that the glass block wasn't there. So there is a dotted line which is going straight, and eventually, since there is a glass block, what we can see that the light ray is getting refracted. It is going towards the normal, since light ray is traveling from air to glass. So it is traveling from rarer to denser medium, and that means the light ray after refraction will bend towards the normal, as you can see in the diagram, and then it comes to another interface from where the light will go from glass to air, because there will be the emergent ray. The emergence, angle of emergence is marked as E, you can see in the diagram, and as the angle of incidence, which is I. And remember one thing, that these two values will be equal. That means angle of incidence and angle of emergence will be equal, because we have the same pair of media alternately. First it is traveling from air to glass, then it is traveling from glass to air, but the angles will remain same, since by alternate angle theorem the angle of refraction are alternate to each other for two normals drawn at 2 points of incidence at the first level and at the second time. So we can see there it will be equal. They will be equal, sorry. So what we can see, that finally the emergent ray will be parallel to the usual path of light, assuming that the block wasn't there. And you can see there is a deviation, and also you can see there is a formula, though it is not required in ICSE class 10 syllabus, it is not included, but in your book you will find it at the bottom of the page, and it actually tells us that what is the amount of shift that occurs due to this refraction between the actual path of ray and the refracted path of ray. And that you can see here the effective deviation is written on the board. The formula is given, where T actually designates the thickness of the block, and sin I minus R is I is angle of incidence, R is angle of refraction, and finally we can see that how the ray is emerging with an emergence angle of E. So you can see the expression, it is the deviation or the lateral displacement, what we can say, is equal to T into sin I minus R divided by cos R. Okay, just remember this and also practice this diagram. This is very important for your ICSE. Alright, so now we have already covered the initial thing of refraction of light through plane surfaces, and hope you have understood the whole thing and also the problems that we did on the board. And now we will be moving into the next lecture, which will be uploaded soon. So by that time, please revise these sessions from your textbook and also solve all the problems. We'll come up with your doubts later on. Okay, so stay at home and revise these sections, and we'll go into the next section, which is the refraction of light through prism. That will come up in the next video. Okay, so I'm Arijit Ray from Accentus, and hope you have understood this. So enjoy the video and keep watching. Thank you.